Destroying projectiles on impact is cool, but sometimes you might want a different behavior. I'm sure you can already guess which. For example, arrows look way more realistic when they stick into targets. You are maybe thinking that it is too difficult to implement for game characters, as they usually use skeletal meshes which usually have animations, because you want an arrow to move along with the skeletal mesh part it's stuck into, right? But actually it is simple. We launched hundreds or maybe thousands of arrows to figure this out. All you need to do is to attach an arrow that hit the character to a skeletal mesh socket. The question is, though, how exactly you can do that and what additional logic you need to make it look realistic. We are starting with the default top-down example provided by Unreal Engine. I changed only two things. The first thing is the character behavior. I made the character to move in order to make it easier to test the arrows behavior. And the second thing is that I created the arrows themselves. How I did it, like both things, you can check out my previous videos, but it's not required to understand what we are going to do today. First thing to do is collision setup. We need to add a new custom channel for our arrows. Go to project settings, then search for object. Here we can create new object channels. I created one called projectile and set default response to block. In the arrow, we need to set up object type to projectile for all arrow components, for the body and for the tail. As we want our arrows to stick in the characters, first thing we want to ensure is that arrows are overlapping with the characters, because we want them to penetrate the characters, right? So I set up all channels besides the world static to overlap. For characters, we are concerned with two components. The first one, the capsule component. As we want arrows to stick in the character mesh, what we want to do is to make this capsule component to ignore our arrows. The arrows have object type projectile. So I set up the capsule to ignore this. The mesh has object type pawn, and this is good because in the arrow we specified that the arrow should overlap with pawns. And here we also set up the character mesh to overlap these projectiles. Another important thing to set up, generate overlap events to true for character mesh and for the arrow. Cool. With this setup, begin overlap event will fire every time an arrow overlaps the character mesh. From this event, we need to set two variables, target actor and target components. We will use it later. We could also use the bond name from the sweep result, but in our case it's not possible, because the arrow is simulated with physics, and for physics objects the sweep result is null. But there is a simple way to overcome this. The next thing we need is the line trace. With the line trace we can get hit location, hit normal and bond name. We'll use it later. But first of all, let's see how we can get trace start and trace end. So we get the root components of our arrow, its word location, its forward vector, and also the bounce. And we simply stretch the line along the x-axis of our root component. Another important thing that can add realism to arrow's behavior is the do not attach condition. First of all, we check the bone. So for example, if the arrow overlapped with the character mesh but didn't hit any bone, we don't want to attach it to the character. The second condition is for hit normal. So here we check if the dot product of the hit normal and the actor forward vector is too small, then we do not attach it. But what exactly does it mean? It basically says that if the hit angle is too sharp, do not attach the arrow. And actually it's quite realistic, because when arrows go too tangent to the target, they usually don't stick in the target. So if the do not attach condition is false, we would like to attach the arrow to the target. But first of all, we disable all the collision, and also we disable the physics for the arrow. We do this in order to prevent any interference with the game logic. And finally, we can use attach actor to component node to attach the arrow to the skeletal mesh of the character. We provide the target component, which is skeletal mesh in our case. And also we provide the socket name. And yeah, it might sound counterintuitive, but you can use bone name as a socket name. Also, you need to change all the three rules to keep world, because by default it's like keep relative. Besides that, you don't need to do anything. Another piece of logic that you might want to have is the penetration depth logic. You see, arrows usually move fast, but the collision processing is discrete. So the arrows might end penetrating too deep or too shallow, which doesn't look good. So here we are providing a constant penetration depth for the arrow. It can be replaced by any game logic you want, but the most simple is the constant, of course. So we get the hit location and then make the center of the arrow penetrate 10 centimeters beyond this point. I think you wouldn't want to implement an arrow that didn't do any damage. So this is the default way to apply some damage in Unreal Engine. All we need to check that the instigator of the arrow is not null. And then we get target's actor controller and apply some damage. So for now it's constant, but it can depend on the arrow speed. It can depend on many other factors. And the last thing, but not the least, is how you can debug this. Because sometimes it might be really unclear why it doesn't work. First thing, of course, is that you can print some data. Target component, target bone, etc. The second thing is that you can draw hit normal. And also the desired location for the arrow from the penetration logic. Another thing is you can do is to enable trace in the line trace component. Compile. Let's see how it looks with the debug enabled. So we can see the line traces in orange, and the blue part is the penetrated part. Also, we can see green arrows for hit normals, and the yellow arrows for the location after penetration. Also, let's review the result. So as we can see, arrows are stuck, the penetration depth is constant, and also we don't have that much arrows that are stuck in a non-realistic way. Also, we can see that the arrows move alongside with character mesh bonds they stuck into, which is good. That is it, fellow game dev and Unreal Engine enthusiasts. I believe you are if you watched until this part of the video, so please consider liking and subscribing for more content like this. And see you in the next videos. Bye bye!